Hi, I quickly would like to take you over the Using Tables in SciToolkit lesson. Obviously, you can all read this yourself, but sometimes it's easy to just quickly talk you over the code. First of all, I recommend you to run the demonstration. If you click on it, you see words as you have in the Stroop task, and you respond with the R, G, B or Y key for responding to the color of the word, not the meaning of the word. So red actually is congruent, but I didn't respond. That says wrong response. So here I need to respond with a Y. Anyway, if you do that, it only goes 5 trials. You see a table with the output, and actually that's quite nice because that is the sort of like output data file that SciToolkit creates for you. In this case, in every line you see what is instructed to SciToolkit in the save line. So now let's go back to the code. First of all, this is the key part for this lesson, the table code. So you can name a table any name you like. I called it my Stroop table. There are 3 columns in it, and what happens is that when SciToolkit runs through a task, it will randomly select one of these lines. So let's assume that it randomly selects this line, where in column 1 it has the word red. That's what will be shown on screen. The to code is both the color and the required key. The color 2 will be green. We have that defined ourselves, and the second key is the G key, and that is an incongruent condition. So keep that in mind. Now the table section, right, is separated from the rest by an empty line. There is this fonts Arial 40. I will not go into that too much, but it just says how big the words will be on screen. Now, important here, the tasks start. The first line just tells SciToolkit which keys are being used. R, G, B, Y, or the first, the second, the third, and the fourth key that SciToolkit knows about. Any other key pressed will be ignored. Then there are some if blocks. There are 4 blocks. And what happens is you see this @ sign. That's really important for understanding tables. So if @2 equals 1, so if double x equal sign, you can also have 1 equal sign. So this means if the value in the second column of the currently selected trial, that's this one, so the value is 2, is equals 1, no, that's not the case, then show text, blah, blah, blah. If the value of the second column equals 2, and that is of course the case for this specific condition, then what it does, it says show text, the text taken from column 1 in the selected trial condition, that's the text red, presented at XY positions 0, 0, that is the screen center, in the color green. And then VI just means the end of this if condition. Now we have 4 different colors, so there are 4 little if blocks. This is one way of coding it. There are other ways of coding it as well, but I thought this is just a nice way to show this. Then it says read key @to 5000. That means SciToolkit here waits for a key press for 5 seconds or 5000 milliseconds. That's the same, right? 5000 milliseconds is 5 seconds, and it looks for it expects the second key, that's the G key, right? Presented here, G. Okay, and when a key has been pressed, any of the keys R, G, B, or Y, because it knows that key 2 has to be pressed, it can determine itself here whether there was an error or not. Directly after the button has been pressed, it clears the last presented stimulus on the screen. I will tell a little bit more about it, but that's clear. Then again, a little if block. If the status is correct, show the text well done at screen center. In this case, it will be presented in color white. Otherwise, so if it's not correct, or there's a timeout which is not correct and says wrong response, or maybe no response, this could be a little bit updated, then there's a delay of 2 seconds. Everything that's still on the screen will be deleted from the screen, and then the information will be saved for this data output file. You've seen that before. So it saves the little text here, the third value, so that would be, for example, do it congruent or incongruent or whatever. Then the value of the word, the response time, and the status. Now you can determine whatever you want to save here. You can save to the data output file. Okay, so that's the task. That runs 5 times. So in the block, you notice you have a block, you say, you have a task list, which tasks are being done. You do the strup task 5 times, right? And here we have task strup. And that's it. Now you might, if you're a beginner in SciToolkit here from this lesson, look at the related lessons. Common terms in psychological studies might be useful to look at. How to present stimuli, how to clear stimuli and so on, how to analyze data. That's a little bit more complicated. So I hope this helps in addition to the text of this lesson.